Good morning, students. Let's begin a new chapter of Standard 11th, and name of chapter is Classification of Element and Periodicity in Properties. Some important topics. First, Dobener's triads. In 1817, a German chemist Dobener identified certain group of three elements. These groups of three elements having similar properties was called triads. When three elements were arranged in order of their increasing atomic masses, the atomic mass of the middle element was roughly the mean of the atomic masses of the two elements. Second topic, Newland law of octaves. When elements were arranged in order of their increasing relative atomic masses, the properties of every 8 elements were similar to the first one, like the eighth mode of a musical scale. This repetition in the properties of the elements is just like the repetition of eighth mode in an octave of music. Third topic, Mendeleev's periodic law. The physical and chemical properties of elements are the periodic function of their atomic masses. And fourth topic is Mendeleev's periodic table. When scientist Mendeleev started his work, 63 elements were known at that time. He selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. Mendeleev's periodic table contains vertical columns called groups and horizontal rows called periods. There were 7 periods and 8 groups. Noble gases were not known at that time, so there was no group of noble gases. The elements in each group of the periodic tables are similar to one another in many properties. The similar properties of the elements are respectively periodically. Fourth, merits of Mendeleev's classification. Mendeleev's periodic law predicted the existence of some elements that had not been discovered at that time. Next topic, limitations of Mendeleev's classification. Mendeleev's periodic law predicted the existence of some elements that had not been discovered at that time. The correct position could not be assigned to the hydrogen in the periodic table, and wrong order of the atomic mass of some elements could not be explained. And third limitation is the position of isotopes could not be explained. And last limitation, uncertainty in prediction of new elements was there. Now, fifth topic, modern periodic law. Properties of elements are the periodic function of their atomic number. And sixth topic, modern periodic table. This table was prepared was Bohr and is based upon the electronic configuration of elements. The table consists of 18 vertical columns called groups and elements having similar outer electronic configurations in their atoms are arranged in the vertical columns, referred to as groups. According to recommendation of International Union of Pure and Applied Chemistry means IUPAC, the groups are numbered from 1 to 18 and the table consists of 7 horizontal rows called periods. The first period contains 2 elements, example hydrogen and helium. The subsequent periods consists of 8, 8, 18, 18 and 12 elements. The 7th period is incomplete and like the 6th period would have a theoretically maximum on the basis of quantum number of 32 elements. In this form of the periodic table, 14 elements of both 6th and 7th periods, which is lanthanides and actinides respectively, are placed in separate panels at the bottom. Nomenclature of an elements with more than 100 atomic number. Digit 0 and name nil and abbreviation N, and digit is 1, then name is un and abbreviation is U. Digit 2 and name is by, abbreviation B. Digit 3, name tri and abbreviation T. Digit 4 and name is quad, abbreviation Q. Name is paint and digit is 5 and abbreviation is P. Digit 6, name hex and abbreviation H. Digit 7, name shift and abbreviation S. Digit 8 and name oct and abbreviation O. And last, digit 9, name N and abbreviation is E. Next topic, we can classify the elements into 4 blocks as for example S block, P block, D block and F block on the type of atomic orbitals that are being filled with electrons. First, S block elements. The elements of group 1 means alkali metals and group 2 means alkaline earth metals which have NS1 and NS2 outermost electronic configuration belong to the S block elements. Second, P block elements. The p block elements comprise those belonging to group 13 to 18, and these together with the S block elements are called the representative elements or main group elements. The outermost electronic configuration varies from NS2 NP3 to NS2 NP6 in each period. Next, D block elements. These are the elements of group 3 to 12 in the center of the periodic table. These are characterized by the filling of inner d orbital by electrons and are therefore referred to as d block elements. These elements have the general outer electronic configuration n-1 d1 to d10 and ns6 to 0 to 2. And last, S block elements. The two rows of elements at the bottom of the periodic table called the lanthanoids, as for example Ce, and atomic number of Ce is 58, and lutetium Lu atomic number 71. After lanthanoids, other is actinoids. Example, Th atomic number 90 and Lr atomic number 103 are characterized by outer electronic configuration n-2 F 1 to 14 n-1 d0 to 1 ns2. The last electron added to each element is filled in F orbital. These two series of elements are hence called the inner transition elements. Variation in atomic radius in period. The atomic size generally decreases across a period. It is because within the period the outer electrons are in the same valence shell and the effective nuclear charge increases as the atomic number increases, resulting in the increased attraction of electrons to the nucleus. Other topic, variation in atomic radius in group. Within a family or vertical column of the periodic table, the atomic radius increases regularly with atomic number. As we descend the groups, the principal quantum number n increases and the valence electrons are further from the nucleus. This happens because the inner energy levels are filled with electrons, which serve to shield the outer electrons from the pull of the nucleus. The size of the atom increases as reflected in the atomic radii. Atomic radii of noble gases. The atomic radii of noble gases are not considered here being monoatomic, their non-bonded radii values are very large. In fact, radius of noble gases should be compared not with the covalent radii but with the van der Waals radii of other elements.